Good day, math learners. For today, we're going to discuss about right triangle similarity theorem. But before that, we're going to recall first our knowledge about the right triangle. Right triangle is a triangle with right angle or an angle that measures 90 degrees. This is an example of a right triangle, and you can easily identify the 90-degree angle there because you can see this indication. Looks like a square. So the parts of a right triangle are the following. First, the hypotenuse. The hypotenuse, it is the opposite side of the right angle of a right triangle. In this example triangle ABC, AC is the hypotenuse, and the hypotenuse class is the longest side of the right triangle. Next, the legs. These are the remaining sides of a right triangle. In this example, triangle ABC, AB, line segment AB, and line segment BC are the legs of the right triangle. Now that you have known what are the different parts of the right triangle, we will proceed now to right triangle similarity theorem. In this theorem, it states that the altitude to the hypotenuse of a right triangle forms two triangles that are similar to each other and to the original triangle. So for example, right triangle ABC, and there's a line from the right angle going to the other side of the triangle that forms a right angle, then this line class is called the altitude. So we can conclude from the theorem that if CD is an altitude of triangle ABC, then we can say that triangle ABC is similar to triangle ACD, and it's also similar to triangle BCD. Most likely, class, you can see three triangles in this figure. Again, triangle ABC, the original triangle, and the two triangles which is CDA and right triangle BCD. Now, let's try to have it as an example. Given right triangle LSN with altitude SM, write the similarity comparing the three triangles on the figure. So first, class, we're going to identify the three triangles on the figure. The first triangle is a right triangle, the original triangle, the right triangle LSN. Next one would be the right triangle SM, because here, this one, SML. Lastly, the right triangle SMN. Therefore, we could write the similarity class, which is triangle LSN is similar to triangle SML and also similar to triangle SMN. And this is now the answer to our problem. And now we're going to proceed to the next discussion. Corollary 1. According to this corollary, the length of the altitude to the hypotenuse of a right triangle is the geometric mean of the lengths of the two segments of the hypotenuse. And next, corollary 2. The length of a leg of a right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse adjacent to the leg. So this is important, class, that you understand the meaning of these two corollaries because we're going to use its ideas in solving some problems. So for you to understand better these two corollaries, we're going to have a table. For example, given an original right triangle ABC, we will tackle first the two similarity. So first, the original triangle ABC and the other right triangle ACD. As you can see, class, according to corollary 2, it says that the leg of the right triangle is the geometric mean of the hypotenuse and the segment adjacent to the leg. So we could say that the hypotenuse there is AB, so there AB, and the segment that is adjacent to leg AC is leg AD. That's why we can have this proportion. AC, which is the leg, so you will write it opposite to each other in this one, and one proportion is AD, which is the segment adjacent to the leg, or that is nearest to the leg, which is AD, and the whole hypotenuse AB. So this is now the formula. AC equals to square root of AD times AB. Next one. How about the other leg, which is BC? So this is the triangle ABC and triangle BCD. So the other leg is BC, so you will write them opposite to each other in a proportion like this. So BC here and BC on the other side. And in one proportion is the leg adjacent to BC. So the segment that is adjacent to BC is BD here. Okay? And also the whole hypotenuse AB. So in the formula, line segment BC is equal to the square root of BD times AB. So this is the description. Leg BC is the geometric mean of the hypotenuse and the adjacent leg, which is BD. Okay, and according to corollary 1, the hypotenuse class, or the altitude the altitude CD, which is this one, is the geometric mean of the two segments it divides, and the two segments it divides is BD and DA or AD. So that's why we will write it according to each other or opposite to each other, CD. Then the two segment it divides, it is AD and BD. Actually, class, that is not only the proportion. You can have another way in writing this one. You could also write it in this way. You could also write AC as long as they are opposite to each other in that way, and the AC, the hypotenuse AB, and the segment that is adjacent to AC, which is AD. So you can write it in this way. As long as AC there, class, will is written in opposite to each other. Also for this leg, so you can write BC in this way. They are opposite to each other. Then here, in this two proportion, you can write the hypotenuse AB, and in the other one, you can write the segment adjacent to BC, which is BD. And lastly, for the altitude CD, so you could write CD in this manner. CD, you should write them opposite to each other. Then in this way, in each ratio or in each proportion, you will write the two segments it divides, which is AD and BD. You can write them interchangeably, class. Okay, it doesn't matter at all. Our answer will be the same. Okay, so now let's try to use this idea in solving some problems. Given right triangle ABC, find the measure of line segment AC, line segment BC, and line segment CD. In this manner, class, we're going to use the ideas or the concepts of two corollaries. We will start with the altitude first. According to Corollary 1, the altitude of the right triangle, which is CD, is the geometric mean. So what you're going to do, class, you're just going to build up your proportion. So we will write CD, which is the altitude, opposite to the proportion, opposite to each other. So in this manner. And then according to Corollary 1, it is the geometric mean of the line segments it divides. So the line segments that it divides is AD and DB. And then we're going to solve now. We will substitute CD. AD is 12 and DB is 3. Then write CD. Then you can say that CD squared, you're going to cross multiply 12 times 3. So CD squared and 12 times 3 is 36. To extract square, you're going to put square root and you can cancel this one. So you could have CD equals square root of 36, that is 6 units. And that would be the measure of line segment CD. So now let's proceed to AC and BC. Let's start with AC first. According to Corollary 2, the leg AC, so we're going, is the geometric mean. So we will write AC, class, in a proportion that they are opposite to each other. Okay? AC is the geometric mean of the hypotenuse, and the hypotenuse is AB. So we'll write AB there. And to the segment adjacent to AC. So in this is AC, and the segment adjacent or close to AC is AD. Okay? AD. There. So we already build up our proportion. Next, we're going to substitute. So AC, we don't know AC, so just write it AC. AB is, of course, 12 plus 3. There, this is 12 and 3. AD is 12 and AC, we don't know, so write AC. Then you cross multiply, class. Cross multiply, that would be AC squared equals to 12 plus 3, that's 15, and 12. So AC squared, 15 times 12, that is 180. Then extract square root so that we can get the value of AC there, and square root of 180, that is 6 square root of 5 units. Since we already talked about radicals, class, we cannot accept decimal answers. So make sure that your answer is in the simplest radical. Next, we are going to get the value or the measure of the next leg, the second leg, which is BC. So we can also write BC in this manner. So there's a proportion. You will just write BC across to each other. Okay? Then it is the geometric mean of the hypotenuse, which is AB, and to the segment adjacent to BC. And the segment adjacent to BC, or the segment that is close to BC, is DB. So now let us substitute. AB is 15, BC we don't know, so write BC there, and DB is 3. So we're going to just cross multiply, so it will become BC squared equals 15 times 3. 15 times 3, that is 45, and you're going to extract square root, so it will become BC square root of 45, that is 3 square root of 5 units. Again, we will not accept decimal answers at this time. Your answer should be in the simplest radical. So we can say that the answer here is, therefore, CD is 6 units, AC is 6 square root of 5 units, and BC is 3 square root of 5 units. And that would be all for example number 2. Let's proceed to example number 3. Find the value of x, y, z given this figure. So it's important again, class, that we're going to use the concepts of the corollaries. So let's start with y first. Okay? So according to corollary 1, the altitude of the right triangle is the geometric mean. So we will write y opposite to each other. And so it will become 4. It divides the segments it divides, which is 4 and x. So cross multiply, it will become y squared times 4x. Since there's no value of x yet, class, we'll just stay our answer as that, and we will just get back on that later on. Okay, let's proceed to the other leg, which is 12. According to corollary 2, the leg of a right triangle is the geometric mean. So therefore, we're going to write 12 in such a way they are opposite to each other in a proportion. It is the geometric mean of the hypotenuse, which is this one. So we will write it as 4 plus x because we don't know what is the value of this x. And to the segment adjacent to that leg. So the segment that is adjacent to 12 is 4. And then, class, we're going to cross multiply. That is 12 times 12 equals 4 times x plus x. 12 times 12, that is 144. And distribute 4, that is 4 times 4, 16. And 4 times x, that's 4x. Then we're going to solve for the value of x here. So you will transpose 16 on the other side, and it will become 144 minus 16 equals 4x. 144 minus 16, that is 128 equals 4x. And we will get rid of 4 by dividing it. So 4x divided by 4 and 128 divided by 4. Cancel out 4, and that will become x equals to 32. We will write it as x equals to 32 units. And since we already got the value of x, we can get back on this problem, class, which is y squared equals 4x. So it will become y squared equals 4. We will substitute x, and we already have the value of x, which is 32. So substitute 32 to x. Y squared equals 4 times 32. That will become 128. And we need to extract the square by putting square root sign on it. And that will become y equals to square root of 128. That will be 8 square root of 2 units. And now we can finalize our answer for y, class. Now let's move on to z. And since z is the leg of the right triangle, and according to corollary 2, it is the geometric mean. So we need to write x opposite to each other in a we will write z opposite to each other in a proportion. And it is the geometric mean of the hypotenuse, again, of the hypotenuse. And the hypotenuse here is 4 plus x. And to the segment adjacent to that leg. And the segment adjacent to the leg z is x because it is closer to x than 4. So we will write x here. Then we will move on to our simplification. So cross multiply, class, it will become z times z and x times 4 plus x. And luckily, we already have the value of x, which is 32. So we'll just substitute 32 to our x here. So 32 equals 4 plus 32. Simplifying it further, class, it will become 32 times 36. 32 times 36, that is 1,152. And we need to extract the square since we're just looking for the value of z, not z squared. So therefore, we can now cancel the squared here, and it will become z equals square root of 1152, that is 24 square root of 2 units. So we can now finalize our answer in this problem class that therefore the value of x is 32 units, the value of y is 8 square root of 2 units, and the value of z is 24 square root of 2 units. And that would be all for this lesson class. I hope you have learned something and you are ready to answer the formative assessment number 1. That would be all, grade 9 math learners. See you on the next video. Thank you and God bless.